Says, which of the following equations have an inverse function? How do you know from the table and graph? For any that do not, how can we limit the domain of the function to ensure that it has an inverse? So let's look at this first function. What I'm going to do first is create a table. So I'm going to actually make this, instead of f of x, I'm going to go ahead and put what it's equal to. So let's type it into our calculator, but we can let's just do this one in our head because that's pretty simple here. So if we do -2, -1, 0, 1, and 2, then we just have to plug those x's in for this x value. So 2 times -2 would be -4. 2 times -1 is -2. 2 times 0 is 0. 2 times 1 is 2, and 2 times 2 is 4. And let's plot some of those points here. So we have -2, -4. Right about there. -1, -2, 0, 0, 1, 2, and 2, 4. And then just sketch our line. The inverse of that can always be found by just switching x and y. So what I'm going to do is go underneath the table and put the inverse. So that was f of x. This is going to be the inverse. So the inverse would be -4, -2, -2, -1, 0, 0, 2, 1, and 4, 2. So you literally take the x and the y and you switch them, and that's the inverse function's new x and y values. They're exactly the opposite. So go to -4, -2, -2, -1, 0, 0, 2, 1, and 4, 2. And we sketch a line there. And it's asking us how do you know from the table and the graph if it's a function? So we're looking at the inverse still. We check to see, does each x have a unique y value? So -4 is with -2, and then we can't tell anywhere else that it's paired up with another number. -2 goes with -1. All of them have a unique y. On the graph, we can tell that they pass the vertical line test. So the inverse is in blue, and that certainly passes our vertical line test. So we can tell two different ways, and we don't have to limit the domain to ensure that it has an inverse. All right, so for B, let's make a table of values. So we're going to do x and x squared. Let's just plug in the same simple numbers, -2, -1, 0, 1, and 2. So -2 squared would be 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. And then let's go ahead and plot those values. So -2 goes with 4. -1 goes with 1. We have 0, 0, 1, 1, and 2, 4. And we get a nice simple little parabola there. Then I'm going to find the inverse function. I'm going to write it down below again. So the inverse function for this one, again, is to switch the x and the y's of the original. So we're going to take the values up there and switch them. So 4, -2, 1, -1, 0, 0, 1, 1, and 4, 2, and plot those points. So if we go to 4, -2, 1, -1, 0, 0, 1, 1, and 4, 2, we end up with a parabola that opens up to the right. And they've asked us, how can we tell if it's a function? Well, this one is not a function because it does not pass the vertical line test because it touches twice. So how could we limit the domain of the function to ensure that it has an inverse? So what we could do is stop at the values that start to have a different number paired with the x. So like 1 with -1 cannot also be paired up with +1. So if we limit the domain, like stop it right there and don't include this other part, then we can plot those points and be safe. So if we limit the domain, then it would only include part of our function, and then it would be an inverse function. So we had 4, -2, 1, -1, 0, 0 is one way we could do it. And the other way would be to limit it on the other half. So like we could have eliminated just on the other side of 0 and plotted those same points like we talked about in an earlier example. So like if we had done the other side of it, that would have been okay too. We just can't plot both or it would not be a function. So it would not pass the vertical line test. So let's jot down that it would be okay if our domain could be x is greater than or equal to 0 or x is less than or equal to 0, but not both. All right, we have one more part over here, part C. So let's make a table of values first. So x goes with 2 to the x power. So this one might be a little easier to just grab some values out of our calculator. So I'm going to type 2 to the x and go to my table. And then, there we go. So let's put in some regular sort of numbers here, like the same ones we've been using. -2, -1, 0, 1, and 2. So -2 we can quickly see goes with 0.25. -1 is with 0.5. 0 goes with 1. 1 goes with 2. And 2 goes with 4. And then we can plot these points. So -2 goes with 0.25. -1 is with 0.5, 0, 1, 1, 2, and 2, 4. So we start to see that exponential curve. Now let's plot the inverse, or like make a table of it first. So if we do the inverse function, our x and y switch places. So we have 0.25, -2, 0.5, -1, 1, 0, 2, 1, and 4, 2. And we go to plot those. So we go 0.25, -2, 0.5, -1, 1, 0, 2, 1, and 4, 2. And draw that graph. So that inverse function is a function for the whole domain. We don't have to limit it. It passes the vertical line test. We can also see that each x in our table has a unique y that it is paired up with. So that one is a function as is. And that is the end of example 6.